Hello and welcome to another video. In this video we're going to be continuing on with the TypeScript line 75 and we're going to be doing encode and decode strings. So in this problem you want to design an algorithm to encode a list of strings to a string, and then you want to be able to decode that string back into a list. So if they have an example here where you have input hello world and then it goes through the encoder and the decoder and it outputs hello world, and that's pretty much what you got to do. So let's say we have a list that says hello world. What we got to do first is make some kind of encoded string that we can then figure out how to decode, right? And there's a bunch of ways you could do this. The easiest way to do it is, so they do say that like we have 256 ASCII characters, so you can literally just pick a character that's not in the 256 ASCII character. So you can pick some like Greek letter or look up the ASCII chart, pick some letter that's not in there, and then just use that to join all your words. So basically you would join like hello and then some Greek letter thing. Let's call this the pound sign. Obviously not a pound, but some random letter that's not in here. So all your words would be separated by this, right? Where like you have a bunch of words by whatever, right? And so on. And then you would pretty much be able to split on this character, and that would be like a one-line solution, something like that. But then they ask you, could you write a generalized algorithm to work on any possible set of characters? So for this one, this wouldn't work, right? Because if you just use an ASCII value outside of the 256, if that character is actually included in their string anyway, like let's say they have, let's say some Greek letter or something, and they actually just have like Greek text, then this would fail. So for a generic algorithm, there's a bunch of ways you could do it, right? This is kind of like an open-ended question. But essentially, one way you could do it is, and this is the way I'm going to do it, is what I'm going to do is, let's say we have this hello world again. Hello, and then we have world. What I'm going to do is, so for every single word, I will add a prefix to it that will give me the word's length. And then we just have to have some kind of character to separate it out that we're going to look for. So that could be anything as long as you have some kind of separator that's not a letter or not a number. So what that's going to look like is, for example, for hello, we're going to say, okay, that's length 5. So we're just going to have 5, and then we can have like a pound sign, and then we're going to have hello. And then for world, it's also length 5, so we'll have 5 and then pound sign. And then world. And we can do this for a bunch of words, right? So we can add like a few more words. Let's say we have like, I don't know, foobar or something. So we can have like another pound sign 6, foobar, as like another word. So let's say we have something like this, right? We have, so our words were hello, world, and foobar, for example. So that is how you would encode it. Now we can figure out like how would we decode it and why this would work. So essentially what we're going to do is we are going to start at the start of the word, right? And we're going to just like start, and we know that every word has a prefix. So we're going to go number by number until we hit the pound sign. So essentially it's going to look like we're going to start at the start of the word. We're going to go number by number. We only have a 5 here. Now we hit a prefix. And then we know everything before the prefix, or not the prefix, the pound sign, is the length of the word. So we're going to take whatever string this is before the pound sign. That's going to be the length of the word that comes after. So this is 5. So we're going to say, okay, so we know after this pound sign, 5 letters are the word. So we're going to take 5 letters, and then we're going to know like after these 5 letters, we will have 2 things. We'll either have an empty string where we're done, or we'll have another number, and then we'll get that number. We'll keep reading from that number till we hit the pound sign. And the reason you need a pound sign is because let's say you didn't have the pound sign, you wouldn't really know, like let's say you have 5, but then your word is like, your word can just be digits, right? Like what if your word was like this? Then the problem is without that pound sign, you would just be reading and you wouldn't know like where your length stops. So that's why I need the pound sign. You just need something different than a number. Anything would work. But essentially that's kind of what we're going to be doing. We're just going to be adding a prefix to every word to tell us like this is the word's length. And then when we're decoding, we will go through, we will get the length, we will get it until we hit the pound sign, and then we can just slice off the next part. Like if we know this is 5, we'll just take 5 characters and then we'll keep maintaining a current index that will like get the next part. So essentially it's going to look like something like, so what we need to do is we need to get length till we hit a pound sign. Then we'll need to get those characters that length after the pound sign, right? Put it in, get the word, and then get next length and so on. Right, so essentially we're just gonna like move up character by character, and every time we pass the pound sign, we know how many characters we need to traverse to get the next word because we'll have that length. And so this is one way to do it. There's probably a bunch of other ways, but this is the way we're gonna code it up. So let's do that. So for encode, we're gonna have a result. So we want, remember, we want to have a actual, so we're gonna actually have a array here, and then we're just gonna join it at the end to make it a string. So we'll have a result. Then we'll go element by element. So for let I equals 0, I is less than string's length here, and I plus plus. We're going to push that prefix. So we're going to push the length with a pound sign, right? So we're going to push, here is going to be str's I dot length. And then we're going to have a pound sign right after to let us know like that's the end of the length. And then we will push the actual word itself. str's I. So it's going to look just like in the picture where you're going to have a prefix number with a pound sign, then the word for every word. Then we can just return this whole thing joined up. So res.join that. Now for the decode, we're going to have a result array here. Right? I guess here you probably want to give a type. So you probably want to have like string array. Makes sense. Okay, and here similarly for this result, we're going to have a string array as well. There we go. And now we're gonna maintain like where we are, like the index of the character we're at. We can call that cur, make it equal to 0, and then we'll just say while. So we're gonna increment cur, but we're gonna increment it different amounts. So we're just gonna use a while loop here. So we're gonna say while cur is less than s.length, like right while there's still something there. Then we're gonna have a start that's gonna be cur. So const start equals cur, which is gonna be like the start of the word or the start of the length or whatever we're using, right? So first, what we need to do is we need to actually get, like, remember our string is length pound word. So we need to keep incrementing cur until we hit a pound sign. So we could say like while s cur does not equal pound sign, let's just increment cur, right? And then we need to actually get that like decode length, right? Like how long the number is. So we can say const decode length equals, and remember this is going to be, since this is a string, we need to actually convert it to a number. So we're going to say number, and then we're going to s.slice. So start is going to be the start of our like word, right? Pretty much. And then it's going to be the start of our length. And remember, cur is on the pound sign. So we need to slice from start to cur, and slice is exclusive. So we will not include cur in the result. So if we have something like 1, 2, 3, 4, 5, or whatever this is, pound sign, cur will be here, start will be here. So if we want this slice, this whole thing here, it will be from start to cur. So now this is going to give us the length. And then we are going to increment cur to go to the next letter, right? So now cur will be past the pound sign. Then we need to actually push that word, right? And how long is the word? Well, let's figure that out. So we do res.push. Then we do another slice. It's going to start at cur, right? So cur is the first letter of the word now. And how long is the word? Well, it's going to be decode length long. So let's say, for example, we have a word like this. So we have a word like word or whatever. We have a bunch of stuff here. The word we want is just world. It's 5 characters long. Cur is right over here. So we would want 5 characters here. So if we do cur and then cur plus decode length, let's say cur is 0, that would be 0 to 5. And it's exclusive, right? So it would be like 0 to 4, really, which is 5 characters. So the way to calculate this is going to be cur plus decode length. So this will actually give us the actual word here. And then we simply want to actually increment cur to this next new index to get a new length, right? So once we put in our word, we need to increment cur to go to the start of the next length of the next word. So cur plus equals decode length. And there we go. And then finally, we should return the result. So essentially what that's going to look like if we go back to our picture really fast, so essentially it would look something like, if we follow this code, right, we'd have some start value that's going to be over here. And then our cur value is going to go to the pound sign. We're going to slice off this. And then that's going to be the length. Then our cur value will come over here. And we know that that's length 5. So we're going to slice off this part. And then we're going to add 5 to cur. So now cur will be over here to get the length of the next word and so on, right? So essentially you're just jumping over from cur. And yeah. And it's okay to use slices here because we're just going to be slicing parts. Like there's no point in adding characters. Slicing is fine, right? Like worst case scenario, you might like make a string twice or something. It's still going to be pretty fast because you're not slicing like character by character. You're taking the whole word. Okay, so now we should just be able to return the result, and now we can test it. See if we have any errors. Looks like we're okay. And let's see. Yeah, and you can see it's pretty efficient. So let's go through the time and the space complexity for this one now. So for the encode, like what are we doing essentially? We're going character by character, and we're pushing this length, right? So the length is going to be way smaller than the actual length of the string. So this is going to be a lot smaller, right? Because for every 10 characters, we're pushing 1 letter. So it's even worded like and then the next one we're only pushing. So like if there's 100 characters, we're only pushing like 3 letters. So this is going to be basically O of 1. Now we are pushing the string. So we're traversing the string, we're pushing it, and we're joining it. So this is O of like the length of the string essentially. And then for the decode, what are we doing here? So we are like moving up cur, and then we are slicing, but we're only slicing like one part at a time, right? So like I said, worst case scenario, you might actually no, we're not every slice is a new element in the array, right? So that's fine. So this is also basically O of n because we are just traversing and we're just slicing as we go, right? So every new word we are putting into the list here. And so actually, I don't think there is another way to do other than slicing. I mean, you could, no, actually, I don't think you can because you need to get like the actual part of the word. So I think this is as efficient as it gets. So it's O of n for both. And then as far as space, I think we aren't using anything extra. Let me take a look here. So here we have this result, but this is just the output. So like we have to be returning that. And like I said, this part is basically negligible compared to the actual length of the word. So we are returning the word, and then we are adding a little bit, but that's basically negligible. And then decode, we have a cur variable, but that's pretty much it, right? And like some other variables, but pretty much it. So space is going to be O of 1 for both of these, because you do have to have a result. You can't avoid that, right? You do have to like return the actual string. So I think that's going to be O of 1, and this is going to be O of 1, because you do have to actually return the list of strings, and you can't return in your time and space complexity. Yeah, so I think that's going to be all for this one. Kind of a weird open-ended one, but kind of cool, I guess. Lets you think about how you would encode and decode strings efficiently. And yeah, like I said, the really easy way to do this is just pick an ASCII character that's not in any of these, like a Greek letter or something. Look up an ASCII, like you can look up an ASCII chart and just look up like whatever ASCII is, like, if this is 0 to 256, just pick something with ASCII value of over 256, and you can just put that in between all your words. So that would work fine, but it wouldn't work, like I said, if they actually have a word with your ASCII character. So that's why we did this solution. But yeah, that's going to be all for this one. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.